Hi, I'm Andrew Searle with IO Industries. Thank you very much for taking the time today to join our webinar and learn about our SDI POV cameras. I'm going to give a good overview that shows a lot of different features and capabilities of these cameras and hopefully show how they might be able to be used in your applications. As an overview, the presentation is going to cover a background of our company and then go through some of the video basics around SDI in general and just give a good understanding from the ground up about what SDI is all about. Then I'll be going into our 2K, 4K, and 8K SDI POV camera series. Talk about some supporting equipment that you can use with these cameras to make them fit into your application. And then just go through some of the examples of applications that we see these cameras used in day to day. So our company was founded in 1991 in London, Ontario. Initially, we were involved in PC-based image capture and processing software for the medical, scientific, and defense-related research areas. And from 1998 onwards, we've been designing specialized digital video recorders capable of recording long sequences of uncompressed video using direct-to-disc recording technology. And this is a technology that we've pioneered and continue to this day. In around 2011, we began producing a series of high-speed, high-resolution video cameras for use in all sorts of applications such as computer vision, broadcasting, and multi-camera video recording systems. And in 2019, we put the two technologies together to produce our VoluCam, which is a multi-format video camera with internal uncompressed recording. At present, we have 20 employees. We're based still in London, Ontario, Canada. We have in-house design and manufacturing that covers all of our electrical and mechanical product design, firmware development, our PC software development, electronic testing and final assembly, and quality assurance and technical support. Currently, we supply products all around the world. We have active customers in over 25 countries. And the major application areas that we get involved in include aerospace and defense testing, augmented reality and virtual reality content generation, scientific research, industrial machine vision, and live event broadcasting. This is just a selection of some of the customers that we work with in the research, aerospace, and defense-related sectors. And more so towards the broadcasting and entertainment markets, here's some of the customers who use our equipment for AR, VR, content generation, entertainment-related applications, and live broadcasting. So to quickly give you a review of the sort of product areas that we produce, the DVR Express series is our family of video recorders. These are multi-channel uncompressed video recorders to support all sorts of different kinds of cameras, whether they're scientific, thermal cameras, industrial cameras, or other sorts of video cameras. This is our platform that we provide to people to record either our own cameras or other third-party cameras. It's a very powerful platform for uncompressed video recording, as well as applying very precise timestamps to the video. Our industrial camera series spans a wide range of high-resolution, high-frame-rate video cameras with fast industrial video outputs such as CameraLink and CoExpress, which are different industrial-style video protocols. These types of cameras are widely used across many applications, including machine vision, scientific research, slow-motion video, and volumetric video capture. They feature interchangeable lenses that have an adjustable field of view, as well as rugged all-metal designs. We use CMOS image sensors from Sony, CMOSIS, G-Pixel, and ON Semiconductor. These cameras range in resolution from 0.4 megapixel up to over 65 megapixels, with frame rates into the hundreds of frames per second, even up to over 1,000 frames per second. The VoluCam is our first series of internal recording cameras. These are compact, multi-format, variable frame rate cameras with internal recording to an SSD. There's a wide range of CMOS sensor options to choose from, coming from either the high resolution standpoint, such as 12 megapixels at 60 frames per second, or 24 megapixels at 60 frames per second, or into the high speed, such as 1080p or 720p over 300 or 400 frames per second. These cameras record raw video internally and have a DNG file workflow. The files are downloaded through a high-speed 10 gigabit Ethernet connection, which gives you remote control, live video, as well as ultra-fast file transfers. These cameras were designed with volumetric video capture in mind, and we've been supplying these to volumetric video capture studios worldwide. This brings us to our SDI POV cameras. These are a compact family of standard rate video cameras using the Serial Digital Interface, or SDI, as their outputs. They also feature interchangeable lenses to adjust your field of view and rugged all-metal designs like our industrial-style cameras. These cameras feature HD, Ultra HD, and 8K formats using Sony and on-semiconductor sensors, and produce broadcast-quality 10-bit video with low noise and high dynamic range. These cameras are remotely adjustable with full paint and shading controls so that you can match them with other cameras. You can see along the bottom we have the 2K SDI Mini, the 4K SDI Mini, and the new 8K SDI. So what's so great about SDI? If you're not familiar already with the Serial Digital Interface, this is a baseband digital video interface developed for point-to-point transport of broadcast quality uncompressed digital video. It's standardized by SMPTE, the Society of Motion Picture and Television Engineers, who publishes all the standards and drives the evolution of SDI as video formats evolve. The great thing about SDI is that there's a broad ecosystem of equipment. Everything from cameras, routers, standards converters, displays, recorders, and transmitters, you name it. There's just a very broad range of different devices and accessories that are out there, and it's very standardized so that everything just works very well together. You're allowed to carry the video data over very long cable lengths, over inexpensive, flexible, and noise-isolated cables, as well as extend even longer through inexpensive fiber optic converters. This is a plug-and-play, low-latency video interface. Just like analog composite video was, SDI is the standard for high-def, ultra-high-def, and 8K, and even beyond. So the SDI interface is designed for carrying standard frame rate video. And what I mean by standard frame rates are really just the frame rates listed here. Everything from 23.98 frames per second to 60 frames per second are the standard frame rates that you typically see carried through SDI video. This is one of the places where you might decide whether SDI is a good solution for you or not. If your application is requiring frame rates that are in this range, it's definitely worth considering using SDI. Right away though, if you're looking to transport or capture higher frame rate video, then SDI might not be the right fit. The same goes for resolutions. SDI supports a range of standard resolutions, which you can see in the table here. This is your resolutions that you commonly hear about when you choose a display, let's say, at home. You're talking about 720p, 1080i, 1080p. These are formats for carrying high definition and beyond resolution videos. And really that's the case, that these are what the SDI format supports and really nothing else beyond that. So again, it comes down to whether an application is requiring video that's going to fit within these specific formats or not. If it is, then that's great. I think SDI can be very useful then in certain applications. But some require resolutions that are beyond this, or in some cases, just rectangular resolutions such as a 1:1 aspect ratio or a 4:3 aspect ratio that aren't necessarily covered under this family of standards. When it comes to link options, you'll hear terms like HD SDI, 3G SDI, 6G SDI, and 12G SDI. And what this really means is it's telling you about the bit rate of the data going through the cable, but that also sort of tells you what the type of formats that are possible through that interface. HD SDI essentially was the evolution of SDI. SDI started out originally just carrying standard definition signals, and then it was evolved into supporting high definition signals using a 1.485 gigabit per second bit rate. This evolved over time where it was capable of originally carrying signals through a single link such as 720p or 1080i or 1080p, but it needed more bandwidth in order to carry, for example, 1080p at 50 or 60 frames per second. So it first migrated into a multi-link format where people used two different cables essentially in what was called dual-link HD SDI. But then this merged together into a single cable infrastructure, which was at twice the bit rate, also known as 3G SDI. So you can see that many of the single-link formats over time have been ganged together, such as with 3G moving into dual-link 3G and quad-link 3G, until such times that 6G and 12G SDI became readily available. So many of the same formats can be transmitted through either one or more SDI cables using different bit rates and therefore different link types. This definitely has an impact on your capabilities for cable lengths. It's something that, of course, needs to be checked by each device as far as how long the cable lengths are allowed. But typically speaking, most systems are able to carry, let's say, a 3G SDI signal a longer distance over coax cable than, let's say, a 12G SDI signal. As well, the number of video IOs that are being used on a video router, let's say, you might need to use multiple connections to use a multi-link 3G signal. Whereas if you could use a 12G SDI signal, then that would cut you down to just a single connection. So when might you consider using SDI POV cameras? Well, the thing is that these can give you the same video signals and the same detailed control over settings as much larger and more expensive broadcast or digital cinema cameras. But by not having internal video recording hardware or having any audio interfaces or other electronics like this, you can have a much smaller camera design and lower cost than those types of cameras. The interchangeable lenses of these types of cameras give you creative control over field of view, which allows these cameras to be repurposed over time. So if you're already working, let's say, within an SDI video infrastructure, SDI POV cameras will integrate seamlessly. They'll allow you to have more camera angles in more places where the larger and more expensive primary cameras just cannot fit or can't be budgeted for. In video production, you might consider using, let's say, an action camera for a tight shot inside a car or other sort of up-close shot. But if you choose instead to use an SDI POV camera, as well as a separate SDI video recorder nearby, this brings you an option with more control over lens selection, settings adjustment, and video file workflow, which gives you a more cinematic result and it helps you match closer to your primary cameras. It's really the case that if you're investigating which sort of cameras to use for a new project, and this could be anything from a research experiment, a remote monitoring system, or some sort of synchronized multi-camera system, there can be several reasons to choose SDI POV cameras. And provided the range of options for the frame rates and the formats match what you need, then it can be a very strong option to consider. So looking again at the lineup that we have, there's 5 main models that I'm going to be discussing. We have the 2K SDI mini series, the 4K SDI mini series, and then the 8K SDI. For the 2K and 4K cameras, there's 2 different versions. You'll see the standard camera as well as the camera with the RS. And you'll notice the difference with that is that we're using a sensor with a rolling shutter. Most of our cameras are primarily using a global shutter sensor, and I'll get into that next. The 2K SDI mini is using a Sony Pregius half-inch sensor. The 2K SDI mini RS and 4K SDI mini RS are both using the Sony Exmor-R IMX183 sensor. The 4K SDI mini uses a 1-inch Sony Pregius IMX305, and the 8K SDI uses an on-semiconductor XGS 45000. Now you can see they all have different sensor sizes, and that's going to affect a lot of lens selection related questions. But generally speaking, the 2K SDI mini is producing 2K formats and below, 2K, 1080p, 1080i, 720p, depending on the format. The 4K SDI mini is for 4K and Ultra HD formats, but also can put out 2K and 1080 formats. And likewise, the 8K SDI is primarily for 8K and UHD TV2 formats, but can also be able to be outputting 4K or UHD signals. These cameras use a range of output interfaces, whether it's 3G or HD SDI, or 12G or 6G SDI, and we'll get into all those options very shortly. I mentioned about the difference between rolling shutter and global shutter, and this is an important decision. There's a major difference in how you can make an image sensor, and there's 2 major categories it'll fall into. And one is called a rolling shutter technique, and the other is called a global shutter. Basically speaking, most of the sensors that are in consumer camera products are in the rolling shutter category. And what this means is that the image is exposed over time, row by row. So it kind of starts at the top row of the picture and it progresses downwards. And this can lead to some different kinds of distortions. Sometimes you won't notice it at all, but in the case when there's very fast motion, if there's some strobes or flashes in the environment, or if there's any kind of vibration in the scene, then this is going to show up as artifacts in your images. And especially in the case with POV cameras, if you might be moving them very quickly or attaching them to a small vehicle, there's just the case that you might not want to have this type of an artifact, or make it look so that this is more of one of the professional cameras that are being used that also has a global shutter type sensor. So our cameras are available with both the global shutter and the rolling shutter type sensors, as I mentioned. It's just an important point to have to choose between. So looking closer at some of the sensor-specific details, the sensors that we use are listed in the table here, and you can see there's some differences with regards to the pixel size, the individual unit pixel sizes, whether they're rolling shutter or global shutter, and then also then what the dynamic range of the sensors are, which is obviously a big question as to what sort of a look this camera is going to be able to provide and how closely it'll match to some more higher performance cameras, for example. But generally speaking, they're all in the same range, and they're capable of producing very good quality images. We would say is definitely a step above the quality of most consumer-grade cameras or sports action cameras in many cases, if configured appropriately. To compare the sensor sizes, again, this kind of comes in line with talking about the lens selections. But you can see that the different sensors here are stacked to show their comparison in size relative to a 35mm full-frame sensor, which would be like a photography-style sensor. So the 8K SDI has the largest sensor. Its size is approximately the Super 35 format. So you're going to need some larger lenses or larger format capable lenses to cover the 8K SDI than you are, for example, the 2K SDI Mini. The 2/3 inch format is sort of a standard for broadcast style cameras. You'll see most of the large news gathering cameras use a 2/3 inch sensor size. So several of the models fall within the 2/3 inch size, but it's important overall to just know the difference and to understand, relatively speaking, the field of view difference for these types of sensors compared to other cameras that'll be in use at the same time. As far as mechanical specifications go, you can see that, again, we try to make these cameras as small as possible. The 2K SDI Mini and 4K SDI Mini, they really just fit in the palm of your hand. The 8K SDI is a little bit larger, but it does have a larger sensor to support as well. Generally speaking, though, you can see the dimensions and the weight are quite small, which gives you the idea that you can fit these cameras definitely into places that much larger cameras can't fit. As for lens options, the 2K and 4K cameras are primarily provided with a C-mount. C-mount, if you're not familiar, is just a threaded mount. There's a wide range of different compact prime and zoom lenses that you can choose from. The 4K SDI Mini also offers a micro four thirds or MFT mount, and this is another type of mount that again allows you to attach certain kinds of lenses, but also adapters that can then convert to other types of mounts as well. The 8K SDI is currently offered with a passive F mount or an active EF mount. We are investigating some other mount options for that as well, including PL mount, to make sure that you can take advantage of some of the latest cinematography style lenses as well. We offer an active C mount to EF mount adapter for the 2K and 4K cameras. And what this lets you do is attach and control any type of EF or EFS type lenses. These are DSLR type lenses, and the nice thing about them is that they have motors inside. So we're actually able to actuate the focus and change the aperture remotely. And in, again, many cases, these cameras are used in remotely positioned applications. So it's nice to be able to have remote control ability over the lenses, where in most cases, the C-mount style lenses are more of a manually adjusted lens. One thing to point out, though, is that zoom is not controlled through this interface. Even if the DSLR lens might have a zoom capability, that's typically meant to be controlled manually, again, by the photographer's hand. And so there's no motors inside the lens to actuate in this case. But we do have some solutions for externally controlling the zoom ring, so we can talk about that if that's necessary. As far as electrical specifications, you can see that the 2K SDI Mini and 4K SDI Mini cameras have a pretty wide DC voltage range input, and this is because they're quite low power and we're able to support battery packs as a result. Broadcast style battery packs often have an accessory port called a DTAP, and this is an 11 to 17 volt output. It ranges depending on the voltage or the charge, I guess, of the battery. So these cameras can be easily powered through these battery packs. As for the 8K SDI, it's designed to have a direct 12 volt input, so a regulated 12 volt is required. Doesn't mean that batteries can't be used, it just means that some concern needs to be made towards ensuring that there's a regulator involved and that that's brought in to make sure that the voltage is just exactly 12 volts. But for power consumption, you can see, many of these cameras are under 10 watts. That means you can get a battery that can power these cameras for the better part of a day if they need to be set out into a remote location, and then you can operate the camera remotely from there. Going back to the SDI output formats, you can see that we support multiple configuration capability for all these cameras. We do this so that you can support various downstream equipment. In the case of the 4K cameras, You can use a single link connection of 12G SDI to provide the full 4K capability at 60 frames per second. But if your equipment is some of the older generation equipment that's meant to use multi-link 3G signals, then you can also then connect the camera through 4 or 2 3G SDI signals. As for the 8K SDI, this is again requiring sort of the latest in terms of connection, which is a quad-link 12G SDI configuration. And that's in order to get 8K video at the full 60 frames per second. But again, if there's a lower frame rate requirement, you can drop down to maybe a dual 12G connection or a quad 6G connection, or just bring it down into a 4K output where it's just outputting a single link 12G or 6G. So we put a lot of flexibility in to make sure that these cameras can be connected to a wide range of equipment. And in some cases, you can connect to multiple devices at the same time using the multiple outputs of the camera. Just to give you a view from the backside, you can see the 2K SDI Mini actually uses the DIN 1.0 2.3 connectors. These are both a push-pull style as well as a thread-locked style for more rugged applications. The 4K SDI Mini and the 8K SDI use the high-density BNC, or HD BNC, also referred to as micro BNC. And you can see below the comparison in size to a standard BNC terminal. So these are quite small contacts. It's able to be very densely packed into the size of the cameras. One of the great things about our cameras is that we include a sync input, and this is using what's called the SMPTE tri-level sync signal type. This is a broadcast standardized reference signal for synchronizing cameras. It's essentially the evolution of what was called Genlock before for analog cameras. This is like a digital or HD Genlock signal. And what this does is it allows you to synchronize multiple cameras so that their SDI outputs are all coming out at exactly the same time. This lets many cameras be accurately synchronized for multi-camera capture applications. And there's a wide range of options for sync generators. You can have little portable sync generators for a couple cameras. There's rack mount sync generators that can distribute sync to many cameras. And some of the vendors that produce these include AJA Video Systems, Blackmagic Design, Ensemble Designs, Lynx Technic, and many more. So how do you configure these cameras? You'll notice that there's no user interface on the cameras themselves. There's no buttons, there's no switches, because primarily these are meant to be remotely controlled cameras. Many other cameras in the world are kind of intended to be controlled or used by an operator. So, right up front, right with the camera. But many of these cameras that we make are produced for reasons and applications where you're just not going to be near the camera. So we make everything completely remotely controllable. All the cameras have a serial control interface. It's an RS485 point-to-point serial connection. And this lets you have cables to control it that are up to 1,000 feet, just over twisted pair copper cable. However, you can extend this, again, very long distances if necessary through Ethernet or other types of interfaces. There's three main control methods that we provide. One is through a handheld remote control and an on-screen menu. So we provide a small keypad that brings up an on-screen menu and lets you adjust almost all of the settings. There's a control software which is used for a Windows computer to control one or more cameras. You can easily configure multiple cameras kind of in one shot, or just have a more graphical user interface to adjust the settings. There's some things that you can do with the control software that you're unable to do with the on-screen menu, such as, let's say, updating the firmware for the cameras or renaming some of the user profiles. But for the most part, you can almost do anything you need to with the on-screen menu, and then the control software is kind of like a fallback option. As it is a serial interface, there are serial-based commands. So if you're going to write your own software, as many of our customers do, we publish a full list of those commands and make it very easy to incorporate control for these cameras into your own software. And lastly, there are remote control panels available from third-party providers. These are the style of control panels that would be used in a live broadcast environment to control any type of the primary cameras that are being used. These kinds of controllers can control one or more cameras over long distances. They're typically using Ethernet or even wireless control methods. And it gives you tactile knobs and buttons for fast access to critical adjustments. So you're not having to search through a menu in order to make a quick adjustment. And then you can just turn a knob instead of having to go up and down on a control inside the menu. So there's a wide variety of options here. CyanView and Starhoy produce remote control panels that are generic for a variety of cameras to be controlled. Sony, again, has sort of the standard for remote control panels for the cameras that they make, but then there's protocol translators that can convert the Sony protocol into our protocol, and those can be used in order to control our cameras with somebody's existing Sony RCP. As far as what can be controlled, there is a huge variety of settings that can be adjusted in these cameras, and that's what a lot of our customers really like, is the direct control over so many different settings and features. It really lets you tune the camera to exactly how you want it to produce video. It lets you really match the cameras to other cameras that you might be using so that you can easily switch back and forth between them and not appear as though you're switching between one grade of camera and another grade of camera. Primarily, you're going to want to set things like your output mode, your video format, your video frame rate. You're going to want to control your exposure. This could be either an automatic adjustment, auto exposure, auto gain, or just completely manual. You can completely control all the settings independently if you need to. White balance, this is again to correct your color. There's a color correction matrix, which even goes a step beyond that. Black level, black balance, master pedestal, these all affect your black to white level transitions. You can adjust saturation, gamma, you can apply lookup tables, the sharpness and detail enhancement, basically all sorts of controls over how the picture looks and how the camera produces video. From there, you can turn on and off whether to use the sync input. You can remotely control a lens if you do have the active EF mount adapter attached. You can do things like moving the focus forward and backwards, do a quick autofocus, or open and close the aperture. You can save all the settings that you're currently using into a number of different user profiles so that you can quickly recall between different settings that you like. And you also choose which setting the camera boots up from. And then you can lastly just read things from the camera, such as the serial number, firmware version, the internal temperature, and such. So there's a very, very broad range of different settings, and we'd be happy to go into more detail about any particular settings that you might have questions about. So just to go through some of the supporting equipment that you might be able to pair with our cameras in order to make a system complete for your application. So lens mount adapters are something that we get asked a lot about. From the C mount on the 2K SDI Mini or 4K SDI Mini, or the Micro Four Thirds mount on the 4K SDI Mini, there's lots of adapters to attach other types of lenses, and these could either be photo camera lenses or digital cinema style lenses with the PL mount. Broadcast style lenses as well, the ENG type lenses with B4 mounts can be adapted as well. So there's a lot of solutions for attaching different kinds of lenses in order to achieve the appropriate optical capabilities that you're looking for, whether it's for a telephoto long range application or a very fisheye wide angle application. We've got a lot of experience making recommendations for that. So just please let us know, what you're looking for, and we'll hopefully be able to find something that would be a good fit. Fiber optic SDI video extenders. These are super helpful if you want to carry the SDI video over very long distances. They could be several hundred meters through multi-mode fiber, or even over 10 kilometers if necessary through single-mode fiber. Some very unique and creative solutions are found by converting the SDI video into fiber. You can multiplex multiple signals together and then carry that over a very long distance. Some converters take care of just transmitting the SDI video, and others also take care of transmitting other interfaces at the same time through the same fiber. The one example from VTEX Media will not only transmit the SDI video, but it'll also transmit the RS485 channel up to the camera, as well as provide a tri-level sync over fiber up to the camera. So it's a kind of an all-in-one package for transmitting all the interfaces that are needed between a receiver station and the camera location. Infrastructure adapters. There's so many different ones to choose. There's format converters, something that'll take a video signal from the camera and convert it into another standard of video, let's say converting from HD to Ultra HD or backwards. There's interface converters, which will take an SDI signal and convert it to another type of video interface, such as HDMI, in order to connect it to a low-cost monitor, or it might convert it even down to an analog video signal. There's video splitters to take a signal from a camera and distribute it across multiple different devices. Video switchers, so that you're taking multiple signals in and then choosing which one comes out to your display. There's just so many different types of devices like this, and that's why you can really build a really interesting system with a bunch of these different parts. Encoders and wireless transmitters. These are devices that'll take the SDI video signal and transmit it and either return it back to being SDI or perhaps convert it so that it exists then after as like an Ethernet video signal. So there's lots of different standards for transmitting video over Ethernet. Again, it just really depends sort of what solution you're looking for there. There's different wireless solutions. Some will provide a low latency, uncompressed point-to-point connection effectively, where it's a wireless connection, but it's just meant for a quick hop across, let's say a stadium, for example. And there's others that are going to encode it and also transmit the lower bandwidth signal. That's helpful for if you're going to be having many different signals, active at the same time. Some devices will also transmit directly into sort of a broadcasting system through, let's say, phone networks. So you're going to bond it to 4G or 5G network directly, and then it can be distributed into live news systems. There's all sorts of different devices out there, and again, based on the sort of professional use of the SDI interface, there's many different options to choose from that are really maintaining that really high quality as well. If you're going to be building a system that might be ingesting SDI video and then doing some processing on it, then you might want to build a computer and put some SDI frame grabbers in them. So there's a big range of different companies making PCI frame grabbers, cards that can go into your computer to connect one or more SDI video signals. And you can see a number of examples listed here. Multi-viewers are a great tool. Again, if you have many different channels to monitor, you can easily get these plug-and-play devices that'll aggregate multiple SDI signals onto one or more displays. And these can be a very low-cost way to monitor many different SDI cameras in a system at one given time. And then monitors themselves. Again, if you're looking for the most lowest latency solution to display the monitoring or display the video from an SDI camera on a monitor, then you're going to look at a monitor that has an SDI video input. Many consumer-grade displays, such as your computer monitors or your televisions at home, would use HDMI video as an input. But for the lowest latency connections, an SDI input is the best, and you'll see that those monitors have very low latency specs as well. So there's monitors that exist that directly accept an SDI signal, so that you don't have to convert it to HDMI first. And these range in size. There's so many different options available, from small smartphone-sized monitors to more desktop-style monitors with very high color rendition capability and very good quality. So there's a very broad range of monitors you can directly connect the SDI cameras into. And then video recorders. So there'd be really two classifications. For video recorders that are going to record the SDI video into a compressed, encoded format, whether it's using an MPEG format or something like Apple ProRes, you could look to a device from AJA Video Systems, Atomos, or Blackmagic Design, for example. Blackmagic Design right now has one of the only 8K recording systems that's available, and you can see that on the screen here. So that's a good match for our 8K SDI. When it comes to uncompressed recording, we actually produce a range of very powerful SDI-based uncompressed video recorders. And these would be if you're really looking to use the SDI video system and collect video for analysis later. If you're looking for video analytics or tracking-based applications, you might not want to have any sort of video compression applied to the signal, whereby if it's in a news gathering or television production applications, it's quite common to use compression methods such as ProRes or MPEG, and then those files can then be immediately brought into a video editing platform. So just some of the examples that we've encountered over the years, definitely in the terms of live sports, just providing more fixed location or point of view shots. You can see several examples across different sports here, and I'm sure the ideas are endless as far as where you could put other cameras in order to give viewers at home a more up-close or immersive view of what's going on in the game. The ideas for where to put these cameras just keep getting more exciting and exciting as time goes on, and especially with the case for more higher resolution options as well. It's just really, again, bringing a better experience to the user at home, who can then be able to see many more closer views of what's happening. We get a lot of motorsports and in-vehicle camera applications with regards to people doing television shows for racing or in-car game shows or things like this. And again, there's lots of options to choose from more of the action camera-based market, but if you're looking for something that can provide a little bit more of a cinematic look or a higher quality, lower noise image, these cameras are very suitable for that as well. And you can see some of the examples where they've been used on the screen here. Aerial camera applications. You can imagine, in many cases, you don't want to have a very large camera flying around, whether it's inside an aircraft or even on a drone. So we've seen a lot of interesting applications using our cameras in these types of aerial applications. You can see on the right, actually, a great example where it was flown on a drone for the Sochi Olympics in 2014. So by being such a small package, they were able to combine our camera and a small wireless SDI transmitter onto this drone, and having such a low weight overall compared to much larger cameras, it let the drone fly for much longer times without having to change batteries in between. So it's just this type of example where you can kind of put together a bunch of pieces and provide a solution that would otherwise be more complicated to deliver. Some of the interesting applications with 4K video and 8K video, you'll hear that it's not the case yet that we're using 8K video, let's say, in live broadcasts today, and it's not coming to your home, let's say, as 8K signals. But there's still very much a case for using 4K and 8K cameras, even in a broadcasting environment where you're just producing an HD signal. And that's to do with digital pan scan applications, where you can have these video processing systems that'll work with a locked-off wide field of view shot from a high-resolution camera, but allow you to define several regions inside the field of view that can each be then their own separate delivered feed, if you can imagine. And this only makes more sense now working with an 8K source, providing even greater levels of detail without having to see any sort of zooming effects, right? In the case of ultra-high resolution video presentations, such as dome projection theaters or just super high resolution video walls, this is again a case where 8K content is being driven. Capability to capture 8K from small cameras is again just going to bring that capability out to the production world, allow them to bring 8K into the world for these types of applications, whether it's from a single camera or from a synchronized set of cameras that can then be used to create a more immersive display. And we've had a lot of experience having our cameras be used in a group for either stereoscopic 3D or 360-degree virtual reality applications. You can see several examples here. People will put together the building blocks of the system, which is the cameras, the sync generators, and the lensing systems. And then from there, take the separate feeds from the cameras and stitch them together or provide them as a stereoscopic view to give you some depth perception. You can build these kind of rigs with larger digital cinema cameras. It has been done, but this is something that can be pretty unwieldy as far as size goes, as well as quite expensive. So using our small SDI POV cameras instead makes the rig pretty small and portable. You can easily connect to a broad range of recorders or directly to streaming systems that'll use real-time processing to stream, let's say, a full 360 feed. Last but not least is aerospace and defense testing. This again comes from more of our background, and it's where we see a lot of our cameras still used today, which are just wild and wacky applications where people need to see video, whether it's to be used for tracking some rocket ascent or being used on a small spacecraft, or even being used to watch in-air refueling happening. So there's just such a broad range where you want to use a small, compact, and rugged camera and have it deliver a reliable, point-to-point video signal. And that's where these cameras really shine. So how can you find out more information? Well, please, from here, visit our website. You can go to our cameras section and learn lots more information about the individual cameras. Look at the features, specifications, photos, and more. You can access the data sheets and the user's manuals. And for some cameras, we have demo videos that you can see as well. Of course, then you can see where to buy these cameras. Please reach out and contact us if you have any questions about anything related to that whatsoever. You're going to see some brief poll questions pop up now. Just if you could provide some feedback to answer those questions, that would be great. From here, we'd be really happy to talk in more detail with you. If you have any particular questions, best thing to do would be to reach out to us through email, and email us at sales@ioindustries.com. There's also our social media you could be following to learn more as we release new products over time. We're going to be giving another webinar like this fairly shortly, particularly about our new VolueCam cameras. We have a couple new models about that, so please stay tuned to hear the scheduling about that. And overall, thank you very much for your attention and learning about these SDI POV cameras. I hope that they'd be suitable for one of your upcoming applications, and we'd love to speak with you more about them. Thanks very much for your time today, and we hope to hear back from you soon.